our next topic, next chapter, in fact, in this physics class is going to be static electricity. So there's two types of electricity. There's static and there's current. And this chapter, or these actually two chapters, 15, 16, are dealing with static electricity and the fields that are created from this. So first we're going to look at is how we define the charge of electrons, or a multiple number of electrons, whether they're current or static. But before we get too into this, make sure you watch this video. The woman on that video is outstanding. She just talks about 150 miles an hour, so you may want to stop the video every now and then. You've had her before for some of our videos, and she's really good at using visual aids to show what we're talking about. So it's a far superior way of doing this than having me explain it with my blah, blah, blah. So watch that before you go any farther if you haven't done so already. Okay, now some topics that was discussed in that was that like charges are going to repel each other and unlike charges are going to attract to each other. Okay, and when we talk about charges, it turns out that the mole is way too large a value for dealing with electrons. So Coulombs, the French scientist who was really the pioneer in all this, defined it as 6.24 times 10 to the 18th electrons as a packet of electrons to work with. And even that's pretty large too, but it's better than the mole. So they now call that a Coulomb after him. I don't know what they called it before that. Who really cares? And when we say E, now notice I don't have a charge on E here. E can be either positively or negatively charged. But if it is negatively charged, then you have to have a negative value for your coulombs. And if it's a positive charge, a positive value for your coulombs. And when we get through the math on this, you're going to have to remember your prefixes. Micro, which means 10 to the negative 6. Nano, which means 10 to the negative 9. And pico, which means 10 to the negative 12. Now when you convert, we don't use the negative exponents. We always put the 1 by the larger label and the positive exponents. So 10 to the 6, 10 to the 9, 10 to the 12 are associated with those three prefixes. One big thing that you need to know about that is the difference between conduction versus induction. Conduction, to help you understand, is if you have a piece of metal, okay, and you have electrons, the buildup of electrons around it, which metals are really good about doing. Metals are really good conductors because they do pass on electrons because they have this shield of electrons around it. We haven't really talked about it much in chemistry, but there is something called a metallic bond in which there's shared electrons around there, which is one of the reasons why it's difficult to get a distinct charge for these metals, but there is a pattern to it. But suffice it to say, they're going to stay there until it touches something. Now, let's say you've got a copper wire right here. Okay? Now, when this copper or metal or whatever it is, let's say a copper strip touches the copper wire, what will happen is the electrons are going to be shared equally across. So what we're going to get is something that looks like this, which I've now just drawn very badly. But now the two are now touching each other, which allows the electrons to flow back and forth. And that is called conduction. And this is why we use a metal wiring in your house to conduct electricity, because they have very little resistance too. There's some resistance, but not much compared to like insulators. Okay, well that's conduction. Now, let's suppose that we have like a plastic dowel, some kind of cylinder, that has also been charged with electrons. And let's say we cut up some pieces of paper. And so we have little pieces of paper near this thing. Now, Plastic is a really good insulator. It holds the charges, it doesn't pass it on very well. However, as this is brought closer to the paper, we notice that the paper starts to get attracted to it. Now, the question is why? Well, because of all these electrons around this dowel here is negative, anything close to it is going to force, because like charges repel, the electrons on the paper are going to line up away from that. Now there's no change in charge in the paper, not at all. But because they've moved, that does create kind of a polar situation where we now have positive, a lack of electrons on one side of the paper because the electrons have gone to the other side because they're repelled. Now, the protons in the paper are not going to move, they're stuck there. So this is all dependent upon what is transponding with the electrons of the paper. So this is what is being perceived here. Now, the fact that they've created this positive-negative polarity in here is causing the paper to be attracted to it. In fact, you'll see the paper actually, if you have paper on a table and you have a dowel like that that is charged, get it close to the paper will jump off the table and connect to the dowel. Why? Because this is called induction. An induction of charges is created by the introduction of a fully charged object towards neutral substances, creating a positive-like attraction to this paper here. And we have many examples of that throughout. But this is the difference between induction and conduction. Now, if the papers jump and attach themselves to the dowel, now conduction takes place where the negative particles then are shared throughout the paper and the dowel. But before that, we have an induction charges, and that's what you see. Okay? So let's talk about the mathematics of the charges here. The first example we have on the script is how many coulombs is a billion electrons? Well, a billion is 1 times 10 to the 9th. All right, so this is just a simple conversion problem. 1 times 10 to the 9th electrons times fraction line, and we want to change electrons to coulombs. Okay, now we're going to put 1 coulomb here, and the definition of a coulomb that I have on the script and that she talked about was 6.24 times 10 to the 18th electrons. Now, because there are electrons, we can make that negative. I don't think I did on the script. I could have, I don't have to. But we know because of electrons, this is going to be negatively charged. And when this occurs, this is going to give us 1.60 times 10 to the 10th, or negative 10th rather, coulombs. And if we wanted to use a prefix of some sort, a picocoulomb is 10 to the negative 12, so this would be equivalent to 160 picocoulombs. Okay? The second example has, if we have 155 picocoulombs, how many protons is that going to be equivalent to? Now remember, a proton is a positively charged particle. It's just not movable like an electron. What they do, when the electrons are gone, the protons then are creating this positive charge. And so this is probably a situation where some induction is taking place. So again, we go 155 picocoulombs. And then I'm going to change to E positive, because that's really what a proton is. It's just a charged particle. Now their masses are completely different, and we don't care about the masses, although there is a question on the practice problems where that would simply be a next step of a conversion, which we're not going to do. I'll let you have the fun to figure that out. But in actuality, I have that the wrong side of the fraction. I should put that down at the bottom. No coulombs on the bottom. So Actually, we don't want to go to protons yet because we got to change the picocoulombs to coulombs. So that's the first thing we got to do. And then we change coulombs to the positive particles. Okay, so now we put our numbers in. There's 1 coulomb. Pico means is really small, so the one goes by the coulomb. And pico, the number that is associated with it is 10 to the positive 12. And remember, we don't use negative exponents in our conversions. Then, 1 coulomb is defined as 6.24 times 10 to the 18th electrons or protons. All right, and I work that out, and I get 9.67 times 10 to the 8th E positive or protons, either one. Their designation means basically the same thing. And that's all there is to that. Okay? Now, the one thing I will suggest and warn you about is that there is going to be a question about how much does an object increase in mass when it gains negative particles. Well, you have to calculate the number of negative particles you have, the electrons, and then multiply that by the mass of 1 electron. For that, that'll be the next step of your conversion. So if you're watching the video, you will figure that out pretty quick. So, your practice problems is at the bottom of the script there. There are 5 questions. The last one is the old balloon and the wall trick. How does that work? I want you to figure that out based upon what the lady said on the video and what I talked about as well. Okay? But be specific. Don't just say, rub, balloon, stuck on wall, the end. No. You're scientists now. Explain why that happened. Okay? Have fun.